Okay, so have you heard about this Benford's-law thing? It's supposed to be like a cheat code for understanding, well, pretty much everything.
It's definitely a fascinating concept. You ready to unlock some hidden knowledge?
Absolutely. Lay it on me.
Well, Benford's law is all about how often certain digits show up. But here's the catch. It's about the digits that come first in real-world data.
So not just any digit, but the one that kicks things off, right?
Exactly. We've got a great article from Built In called Benford's Law, the First Digit Law Explained, to help us navigate this deep dive.
Perfect. Love having a guide for these things. So is this telling us the universe has a favorite number or something?
Haha, maybe. See, we usually assume numbers in big data sets are, like, evenly spread out. Each digit, that's its fair share.
Makes sense. Randomness and all that.
Right. But Benford's law swoops in and says, nope, not so fast. He gives us the specific pattern for how often those leading digits actually pop up.
Okay, I'm going to need an example. My brain is not quite wrapping around this yet.
All right, picture this. All the rivers in the world, each with its own length. Benford's law predicts that way more of those lengths will start with the digit 1 than, say, an 8 or 9.
No way. Really? Like more rivers are 1,000-something miles long than 8,000-something? That's wild. Oh, wait, the article even has this cool graph showing how each digit stacks up.
It's a great visual, right?
Yeah, so this isn't just some theory someone cooked up. There's actual data backing it up.
Precisely. And the story of how this law came about is a pretty interesting one, too.
Oh, God, love a good origin story. It all started with a dirty library book, didn't it?
Yep, you got it. Back in 1881, an astronomer named Simon Newcomb noticed that the first pages of his logarithm tables were way more worn out than the ones later in the book.
Makes sense. People were hitting up those ones way more often. But it's wild that he connected that to, well, anything.
Right. He saw a pattern emerging. Then, decades later, a physicist named Frank Benford really dug in. He analyzed something like 20,000 data points from all sorts of sources, areas of rivers, populations, even things like molecular weights.
So we're talking all over the map.
Yeah, and guess what? Benford's law held true across all of them.
It's like he was playing a giant game of number bingo and realized the universe kept calling out the same numbers first. Wait, but this isn't just some random quirk of nature, right? There's actual math behind it.
You nailed it. In the 90s, a mathematician named Theodore Hill actually proved Benford's law. So it's not just an observation, it's like this fundamental mathematical principle.
Okay, my mind is officially blown. So we've got what it is and a bit of the history. But tell me, where else does this law show up? It can't just be rivers and populations, right?
Oh, you'd be surprised. Think electricity bills, stock prices, even death rates. You name it, Benford's law might be hiding in there somewhere.
Hold on, are you telling me if I look at all the addresses on my street, more of them will probably start with a 1 than any other number?
Uh-huh. Very possible. Benford's law tends to be true for data that happens naturally, without any limits or manipulations.
This is seriously messing with my perception of reality.
It's a powerful concept, that's for sure.
Okay, this is all super cool, but I have to ask, why should I care about this law? What's the practical takeaway here?
That's the key question. Because Benford's law isn't just some math puzzle. It's like a tool for understanding the world, and maybe even changing how you think.
All right, lay it on me. I'm ready for a brain upgrade.
Okay, first off, it helps us understand how things are distributed, from the tiniest particles to, well, the entire universe. Recognizing this pattern helps us see order in what we might think is random.
Whoa, so it's like a secret code for decoding the universe. I'm into it.
It also makes you a more critical thinker. Being aware of Benford's law means you'll start to question data in a way you didn't before. You'll notice things that other people might miss.
I like the sound of that. Being more informed, more insightful. It's always a good thing. Plus, I hear there's this whole fraud-busting angle to Benford's law. And that's where things get really interesting.
You're right. That's where things get especially fascinating. Yeah, so it all comes down to how we humans make up numbers. We're actually pretty bad at faking randomness.
So when we try to, fudge the numbers, we don't unconsciously follow Benford's law.
Exactly. The data sets we make up tend to have a more even distribution of digits, not that natural drop-off that Benford's law predicts.
Okay, so if someone's cooking the books, their fake numbers won't follow this natural pattern. It's like a mathematical lie detector test.
You could say that. Think about financial statements, for example. Auditors can use Benford's law to analyze things like sales figures, expenses, inventory, all those numbers that make up a company's financial picture.
So let's say I'm an auditor looking at a company's books. What kind of red flags would I be looking for?
Well, imagine you're looking at a list of transactions, right?
Mm.
If you see way more transactions starting with, say, 7, 8, or 9 than you'd expect based on Benford's law, that might be a sign that something fishy's going on.
Wait, hold on. More high numbers at the beginning is suspicious? Because Benford's law says those digits should be less common as leading digits, right?
That's the idea.
Yeah.
Of course, it's not foolproof. It's not like every time you see a bunch of 9s, you've found a fraudster.
Right. It's more like a clue, like a starting point. Tells you where to dig deeper.
Exactly. It's like a smoke detector. Doesn't pinpoint the fire, but tells you there might be one. Better grab the extinguisher just in case.
Okay, that's a great analogy. So in our financial statement example, that suspicious digit pattern would prompt the auditor to investigate those transactions more closely, maybe look for other inconsistencies.
Precisely. And Benford's law isn't limited to just finance. It can also be a powerful tool in scientific research.
Oh, wow, really? So even in science, where it's all supposed to be about facts and data, there's still room for, let's call it creative data handling.
Sadly, yes. Scientists are human too. And sometimes there's pressure to publish groundbreaking results, which can lead to, let's just say, questionable practices.
I guess even in the pursuit of knowledge, things can go astray.
Unfortunately, that's true. But thankfully, Benford's law can act as a sort of safeguard, a way to double-check the integrity of the data.
Okay, so walk me through this. How would a scientist actually use Benford's law to spot potential problems?
All right, so picture a study where researchers are analyzing a large data set, trying to understand, say, the effectiveness of a new drug. They run their experiments, collect the data, and then they use statistical models to analyze the results.
Okay, so they'll report things like p-values, regression coefficients. Wait, what are those exactly?
Great question. So p-values basically tell us how likely it is that the results they observed happened just by pure chance. A very low p-value means the results are statistically significant, less likely to be a fluke.
So low p-value means the drug's probably doing something, not just random noise in the data.
Exactly. Now, regression coefficients, those tell us the strength and direction of the relationship between different variables in the study. For example, a positive coefficient might tell us that higher doses of the drug are linked to better outcomes.
Got it. So these are important numbers for understanding what the study actually found.
Yeah, exactly. But here's the thing. If the researchers have, shall we say, massaged their data, those p-values and regression coefficients might not follow Benford's law.
So those numbers, those seemingly objective measures of how statistically significant something is, they might actually be hiding something fishy. That's wild.
It is. It's like those suspicious financial transactions we talked about.
Mm.
If those p-values and coefficients don't have that expected distribution of first digits, it's a sign to take a closer look at the study and the data behind it.
I'm seeing Benford's law everywhere now. It's like having this secret decoder ring for spotting potential problems. And it's amazing to me that this simple idea about how often certain digits show up first can be so powerful.
That's the beauty of math, right?
Yeah.
It often reveals unexpected connections, patterns we wouldn't see otherwise. And in this case, those patterns can help us separate fact from fiction, which is so important these days.
Absolutely. We're just bombarded with information constantly, and it's getting harder and harder to know what to trust. But, I'm also starting to wonder about the limitations of Benford's law. Are there situations where it just doesn't apply?
That's a great question. Benford's law isn't magic, and it's definitely important to understand when it's a useful tool and when we need to be more cautious.
Okay, so when should we be careful about using it?
Well, first off, remember it works best with large data sets. The more numbers you have, the more likely they are to follow that Benford's pattern.
Makes sense. A handful of numbers could be anything, but thousands, millions, that's where you start to see those underlying patterns.
Exactly. And the data needs to be relatively unconstrained. If there are, artificial limits on the numbers, Benford's law might not hold true.
Can you give me an example of what you mean by artificial limits?
Sure, imagine you're looking at the heights of adult humans. Most adults fall within a fairly narrow height range, right? So that data wouldn't necessarily follow Benford's law because it's restricted by, biological factors.
Ah, okay. The numbers can only be so high or so low because of how humans actually grow.
Exactly. And it's important to remember that Benford's law is a statistical tool. It can highlight anomalies, but it doesn't give us a definitive answer.
So it's like a starting point for an investigation, not the final verdict.
Precisely. If you see deviations from Benford's law, it doesn't automatically mean fraud or manipulation. It's a sign that it's worth taking a closer look. maybe using other tools and techniques to see what's really going on.
Like a detective's hunch gives you a lead, but you still need to gather the evidence. But I have to say, this whole conversation has been really eye-opening. I'm starting to see Benford's law everywhere now.
That's what's so exciting about it. Once you're aware of it, you start noticing it in unexpected places.
I bet I'll never look at my grocery receipts the same way again. But beyond the specifics of how we use this law, I'm really curious about the bigger picture implications. What does it tell us about information itself?
That's a fascinating question, and it takes us into some pretty deep territory. Because Benford's law isn't just about catching bad guys or scrutinizing data. It's about understanding the fundamental fabric of information.
Okay, you've definitely got my attention. Tell me more.
We live in a world that's just overflowing with data, right? Numbers, statistics, figures, charts. It's everywhere we look.
And it can be absolutely overwhelming.
Exactly. And in this flood of information, it's so easy to lose sight of what's real and what's not.
Which is why critical thinking is more important now than ever. We need tools to help us navigate this information overload.
And that's where Benford's law comes in. It reminds us that even in seemingly random data, there are often underlying patterns. And by understanding those patterns, we can gain a deeper understanding of how the world actually works, make more informed decisions.
So it's not just about the numbers themselves, but about what those numbers represent, about using math to decode the stories hidden within the data.
Precisely. It's like using a mathematical lens to see the world in a new light.
And in doing so, we might just uncover some surprising truths. But, we've talked about finance, science. I'm curious about other areas where Benford's law might be applied. Feels like the possibilities are endless.
You're absolutely right. The versatility of Benford's law is one of the things that makes it so fascinating.
What?
And we're really only just beginning to explore its full potential.
All right, I'm ready for more. What other intriguing examples are out there?
Well, one area where it's shown a lot of promise is in election forensics.
Wait, really? You mean we can use math to, help ensure fair elections?
Yeah. It's pretty remarkable. Researchers have been looking at using Benford's law to analyze voting patterns, seeing if there are any weird deviations that might point to irregularities.
So, if certain precincts or districts have vote counts that just don't line up with what Benford's law predicts, it could be a sign that something's off.
That's the idea. It's not a foolproof method, of course, but it's another tool in the toolbox. Adds another layer of scrutiny.
That's incredible. It feels like this law has implications for democracy itself.
It definitely highlights how important data integrity is across all aspects of society, really.
For sure. And how math can play a role in protecting those systems.
Exactly.
It's like having this, mathematical watchdog keeping an eye on things, making sure the numbers add up fairly.
I like that.
And beyond elections, I've heard Benford's law being used for other things, too, like auditing tax returns, catching insurance fraud, even spotting fake social media accounts.
Oh, yeah, absolutely. It's incredibly versatile.
The possibilities seem endless. It's like this one law just unlocks a whole new way of seeing the world.
It really speaks to the power of observation, right? And how seemingly unrelated fields can be connected in surprising ways.
Yeah, for sure. Okay, so we've covered a lot of really interesting applications for Benford's law, but for our listeners out there, what's the key takeaway? What should they be thinking about as they go about their day?
If I had to boil it down to one thing, I'd say it's this. Benford's law is a reminder that the world is full of hidden patterns. And by paying attention to those patterns, we can gain a deeper understanding of how things actually work.
And that understanding can help us make smarter decisions, right, in all parts of our lives.
Absolutely. From evaluating financial statements to looking at scientific claims to just being more aware of the information we consume, Benford's law gives us this framework for thinking critically, making better choices.
So it's not just about crunching numbers, but about using those numbers to understand the world around us. That's a really powerful idea.
It is, and it's all thanks to this simple yet profound mathematical principle, this idea about how first digits are distributed.
Well, I think it's safe to say this has been one of our most mind-bending deep dives yet. I've learned so much, and I feel like I have a whole new set of tools for navigating the world of data.
I've really enjoyed exploring this topic with you. It's always exciting to see how a seemingly simple concept can have such profound implications.
Me too. Before we wrap up, is there anything else you want to add?
Just this. Remember, Benford's law isn't some abstract idea. It's a tool you can actually use in your own life. So next time you see a bunch of numbers, whether it's in a news article, a financial report, even just your grocery receipt, take a second to think about those first digits. You might be surprised by what you discover.
That's great advice. So, to all our listeners out there, stay curious, stay skeptical, and keep those first digits in mind. You never know what hidden patterns you might uncover.
Until next time.
Happy exploring.